All right, let me get going then. Now, sorry I can't be there. I'm stuck in Australia. I will be in your town in 2 weeks' time, but I couldn't bring my plane forward. Now, today I want to show you we're a software development house, and as a bit of a side project, we thought we'd sort of dabble in some space software. So I want to show you that today and let you play with it if you'd like. So we're a spatial data company, and we predominantly collect data and display it for the earth sciences and universities and mining companies. So in showing you what we've done for the space and Lunar, we wanted to show you what we do on Earth, because many of the things that we do with our Earth data, we can do with the moon data. So, and of course, lunar samples we have less of, but we're seeing that there's a lot more future ideas about collecting more samples. So we feel that our platform is a good place to start storing some of this data. So for Earth, we provide clean, standardized data, and we mine that from scientific literature, or we get it directly from machines that produce data in labs. And we store this in a relational database in data models that we've designed with some experts that contain all the metadata, so you can analyze this, the information that you're collecting. And on top of these models, we put our UI, and you can see there's a picture of there of Australia with some, that happens to be some Vision Track data in that picture. So this is just an example of one of the data models. You probably won't be able to see it that well, and that doesn't really matter. But what it's trying to show that we've just got a structured database that you can put data into. And we've also got, we can ingest data either using Excel spreadsheets or via an API. So it makes it easy to get data into our system. And I'll just quickly show you a few pictures of some of our Earth-based data. So this is geochemistry data set that's in Western Australia. And that's just showing the nickel highlighted, and you can mouse over information and find out more about it. You can do things like, this is a picture of some PNG geochemistry data, and that's just our contouring tool. So you can actually get a better picture of the distribution of the elements by using tools like that. And then we've got tools such as drawing swath profiles, so you can see the data in its sort of spatial context with, elevation. And then, of course, you can start plotting them in fairly standard plots, and you can see this is geochemistry data, and they're just using things like rare earth plots and trace element plots, and you can compare them. You can see that we've got a normalization in the chondrite there, so you can start comparing, looking at the data and looking at it more in depth. And we've got classification plots up the top there, like that you can start classifying rocks. And this is another type of data, just to show that we just don't do geochemistry. This is Vision Track data. And this is just showing that you can select multiple populations. And I've selected different populations down the east coast of Australia there to compare them. And you can see that they all have different characteristics there. So we can do all those things. And as we were doing, collecting all this data and writing this software, we kept on seeing articles such as this and hearing about Artemis. And we're going, well, we collect data, and So why can't, what can we do in this space to sort of get involved? So there's no reason why we can't look at data from space and on the lunar surface. Especially the old data that we've had a look at from the Lunar and Apollo missions is all geochemistry data, the rocks brought back to Earth and then analysed in labs. So it's exactly the same sort of metadata as we have for Earth samples. And so we decided to create LithoSpace. So we're using existing projections of the moon and its geology, and then adopting that into our system, and then using all the tools that are available in our system. But of course, wasn't particularly easy. It's not like the space data is in a beautiful relational database form, and you can just put it into our system. We had to go hunting it. You know, some of it was in PDFs, so we had to strip it out of the PDFs. We also, we could find the locations of where the landing craft landed. That was quite easy, but then where the astronaut took the rock from was a different matter. So we had some students from one of the universities here that were doing a space science degree, and they came and helped us, and they found a lot of the data. So we ended up putting it in our system. So I'm just gonna, oh, sorry, I'll just go back to that. So you can see there, you know, that's just showing you the samples in our system essentially, which you probably have all seen those locations before. So this is just a little video. Hopefully it comes through okay. So you can see, you can view the data. It's not too many points in our database, but we're hoping over the next decades that there'll be lots more. Of course, these are the lunar craft. So, you know, you can put things like the images in there. So when you mouse over it, you can see that kind of information. That was viewing it as at a sample-centric view, but now we're looking at the geochemistry view. We can select those, and as we saw for the Earth-based samples, we can start looking at the trace element plots and the classification plots. You can see that they're all of those samples there are quite primitive, but you're not really seeing anything new here because it's data that's been around for 50 years, but it's more showing how we can put this data in quite quickly and then start playing with it. And you can see that we've put the USGS geology in there. So then you can project the samples on that and see where the samples are in the context of the geology. Oh, that's going to play again. I don't want it to do that. So here we are. This is just a more detailed look at the lunar samples from 16, 20, and 24. Again, they're sort of, the samples are plotting down in the primitive, so they're primitive basalts essentially. But all of these plots, you can change the axes, and you can, so in this plot up in the top right, you can plot whatever elements are in the system against each other. So you can start to invent your own stories. You can start to look at this data in other ways. Because it's in our relational database, it makes it easy to compare different things. Now I don't have too long. So I've only got a minute or so left. So we've got you can do the same thing with the Apollo data. There's a bit more of a spread in the data there, which is interesting, but it's showing the same sort of things. So we figure that more data is coming over the next few years, and even this afternoon I've heard a lot of you say such things. So we feel that the platform we're developing, that the data can easily go into that, and then you could start using it to start to understand the data in different ways. So, you know, it's anyone can go and use this software. It's free. It's just an offshoot of our main software. So we're not charging anyone for it. It's just community use. And it'll be coming out in July. We're probably going to change the URL to be called, it'll be called LithoSpace or something like that. But for the moment, if you wanted to go and see it, you can go and visit it, that URL. Thank you.